welcome back to our YouTube channel. So if you're new here, my name is Stifler. I welcome you. You can just quickly go and subscribe to our YouTube channel, or you can wait and watch this video. And if you enjoyed this, if you like this, you can just subscribe to our channel, and I promise that I'll keep on bringing you new content that will make you pass, that will unlock all the hidden thoughts in your mind, and you will ace your exams. So today we are on vertical projectile. We are just doing typical exam questions. I will do a couple of questions that can help you understand this better, and that can help you to tackle any question that you can meet in the exams. So before wasting time, let's just get straight into it. So we are having this question, and I also explained that this document that I'm using, I will leave the link in the description. You can go and download it on my Google Drive, right? And you can also use it to answer some couple of questions on that. So we are having this question. It is saying a small disk C is thrown vertically upwards at the speed of 15 meters per second from the edge of the roof of a building of height 30 meters. After 0.5 seconds, a small disk B is shot vertically upwards from the foot of the building at a speed of 40 meters per second in order to hit disk C. And they said ignore the effects of air resistance. So before answering any question, what you have to do is to do a small diagram that will help you to understand everything. So here it's fortunate they drew something for us, so you can just have C there. So this is disk C that is thrown upwards at 15 meters per second. So everything that you know about C, let's write it down. So we are having initial velocity of C as 15, but since I said in these videos I'm going to check our down as positive, so this will be negative 15 meters per second since it's going up. And we also have what? That's all we have, and we know that it is at a height of 30 meters above the ground. So it's 30 meters above the ground. And what do we know about ball B? So we know that ball B, it is thrown upwards, it is shot upwards at V initial being equals to negative 40 meters per second, right? So that's what we know, and we know that time it is thrown at time 0.5 seconds after C. So this is what we know. So now let's answer the questions that we have here. So we have the question, the first one is saying explain the term projectile. So how do we explain projectile? So we know that projectile is an object in motion under the influence of gravitational force only. Gravitational force only, and you can get your 2 marks there, right? So the words that you should not leave out when you are writing it's the object. You should not leave out the object, and also influence of gravitational force only. So these two phrases are the ones that can make you gain your marks, right? However you put it, but it must make sense in this sense with these words included, right? So 3.2.1, it says calculate the time taken by disk C to reach the maximum height. So like I explained that at the maximum height the velocity is 0. So it means that the velocity there at the maximum height is 0. So how do you calculate now the time taken by disk C to reach the maximum height? So it means that we can say this formula Vf is equals to V initial plus acceleration changing time, since it is having final velocity, initial velocity, acceleration and time, and all of this we have. So acceleration, it is always constant. It is 9.8 meters per square second downwards always, right? So it should be a positive one. So our VF is 0 and our V initial is negative 15 plus 9.8 change in time. We can bring this that side or however you wish to do. So our 9.8 change in time will be equals to 15. And we can divide both sides by 9.8. So our time now becomes 1.53 seconds. Like that. So it took 1.53 seconds to get to the maximum height. So 3.2.2 now, it says calculate the maximum height above the ground reached by disc C. So the question says above the ground. So it means that from also this building, so above the ground. So this is the ground, right? So let's first calculate the maximum height it will reach from this top. Then we can add this height that it will reach to get to its maximum height plus this 30 meters, right? So let's see. Vf squared is equals to V initial squared plus 2 acceleration changing y. So our final velocity is 0. Our initial velocity negative 15 squared plus 2 acceleration. So acceleration is 9.8 and our changing y. So it means that now our 0 becomes 15, negative 15 squared gives us 225, and 2 multiplied by 9.8 is 19.6. So it means that this coming this side, negative 19.6, changing y becomes 225. And dividing both sides by negative 19.6, so it means that now our changing y becomes, after using a calculator, we see that this becomes negative 19.6, like that. Making sure. So this is should be negative 11.48 meters. But you know that negative means upwards, so it means that our displacement here, it is 11.48 meters upwards. So this is our displacement. So to find the total height now this ball reaches above the ground, it means that we are going to add this plus 30. So it means that our displacement now becomes 30 plus 11.48. And this gives us 41.48 meters above the ground. So this is our answer to 3.2.2. So now let's move to 3.3. So this 3.3 is saying calculate the time from the moment disk C was thrown upwards until the time ball B hits the disc. So this one now needs a lot of things. It needs you to think outside the box, right? So we have to take, so for two things to collide, what must happen? So for two things to collide, they must reach at the same place at the same time. So these objects must reach the same place at the same time. So what do we do now if we know that these things, they will reach the same place at the same time? So it means that the time and also the displacement must be written in relation to each other so that we can calculate using that. So if we check here, this ball was thrown 0.5 seconds after this was thrown, right? So if they arrive at the same place at the same time, it means that this can take t seconds to get to a place, right? So this is disc C. So it means that C can arrive at a place at t seconds. But just because this was thrown 0.5 seconds later, so it means that it will have to travel fast enough to get to this place at this time, right? So it means that this will arrive at this place at t minus 0.5 seconds. So this is B. It should be arriving at that place at that time, right? So that's the meaning of this. And the other thing that we should take into consideration, because we need them to reach a certain space there or certain place there where also the displacement is the same or the distance is the same. So this one was thrown at 30 meters above the ground, like that, right? So it means that any position it reaches can become changing y. So any distance that it will reach, it will be changed in y. But how can we write this now in terms of that? So already we can see that this is already 30 meters above the ground, and this one is on the ground. So it means that for this to reach at that same place at the same time, so it means that the displacement of this should be changing y minus 30, because it is 30 meters behind. This one is 30 meters behind. Can you see that? So it means that we can use a simultaneous equation on this to try to find the time. So we are going to use the same formula for different objects to try to work on it simultaneously. So when it comes to this disk C, we can see that our displacement, so we need to find the formula with displacement and also time, right? So according to this, the displacement is equal to V initial change in time plus half acceleration change in time squared. So what is our change in displacement? It is just displacement, and initial velocity there, it is negative 15, and then time, it is just time like that, plus half acceleration 9.8, and then time squared, right? So it means that this now becomes change in y being the same as negative 15t plus 4,9 t squared, right? So this means just our displacement can be calculated by 4,9 t squared minus 15 t. So we can call this our equation 1. I'm sure you are familiar with simultaneous equations. So we can go to our disk B now. So what do we know about disk B? Also, we can use the same formula, changing y being the same as v initial change in time plus half acceleration change in time squared. So our change in displacement can become change in y minus 30, because it is 30 meters behind of disk C, right? Should be equals to v initial. This was shot at 40 meters per second. So this is negative 40 multiplied by the change in time of this, it is t minus 0.5, which is half, right? Plus half 9.8 t minus half squared, like that, right? So now how can we go on with this equation? So this can be simply change in y minus 30 being equals to this multiplied by that, that's negative 40 t, this and that, that's positive 20, like that, right? And now this will give us 4,9, and this inside the bracket will just give us t squared minus t, because it will be minus half t minus half t, it will give us minus 1, and then plus a quarter, like that, because negative half squared, it will give us positive quarter, like that. So now it means that our change in y minus 30 becomes negative 40t plus 49 over 40 with this no, that should be plus 20, and then plus 4,9 t squared minus 4,9 t, and 4,9 multiplied by a quarter, that just give us 49. So this will be plus 49 over 40, like that. Can you see that? Yes. So now it means that our displacement, so our displacement minus 30 will be equal to 4,9 t squared, right? And then what do we have there? The like terms, we have this and that. So that will give us negative 44,9 t, and 20 plus 49 over 40, that will just give us plus 21,225, like that. So taking 30 that side, so it means that our changing y now becomes 4,9 t squared minus 44,9 t, and when 30 goes that side, it will add with that one, and it will give us plus 51,225. So this, you can call it equation 2. So now we are having equation 2 and equation 1. So we know that if we are having two equations that are having the same of these variables, we can equate them, right? So both equations are starting with changing y, right? So we can say equation 1 is equals to equation 2. So this will be 4,9 t squared minus 15t will be equals to 4,9 t squared minus 44,9 t plus 51,225. So we can see that we're having the same of this both sides. Now we can bring this side. So negative 15t, and that it will give us negative, no, it will give us positive, because this is negative and the bigger one will be positive this side. So it will give us 29.9t being equals to 51.225. Now we can divide both sides by 29,9. So our t can become 1.71 seconds. Like that. So that's how we can work with a question like that. It deserves 6 marks. It deserves, right? So it needed you to understand how to make something in relationship to the other, right? So we cannot calculate this question simultaneously by just placing the values. We need to make everything in relationship to the other, just like the time. So this time is t, and that one is t minus 0.5, because it was thrown 0.5 seconds later. And also the displacement, this was thrown at a distance that is negative 30 from where this one is, right? So that's why we did that. So let's move on to the second question and see how we can do this. So let's see this second question that we are having here. So they said, in a competition, participants must attempt to throw a ball vertically upwards past point P, marked on a tall vertical pole, like that. So point T is 3.7 meters above the ground. Point T may or may not be the highest point during the motion of the ball. So one participant throws a ball vertically upwards at a velocity of 7.5 meters per second from point that is 1.6 above the ground, as shown in the diagram below. Ignore all the effects of a resistance. So again, we can write all that we know about this, right? So the initial velocity of this ball, it is 7.5, but since it is going up, it will be negative 7.5 meters per second. and acceleration, we know that it is always 9.8 meters per square second, which is positive, right? So in the first question they said, in which direction is the net force acting on the ball while it moves towards point P? So the direction of the net force is downwards. And the reason being why it is downwards, it is because only Fg is acting on the object. Or you can write the object is in free fall. The object is in free fall. Or you can say this is a projectile object, right? This is a projectile. So 3.2, they said, calculate the time taken by the ball to reach its highest point. So we know that if you want the highest point, we know that the highest point, the velocity is 0, right? Because at the maximum height, the velocity is 0. So now we can use Vf is equals to V initial plus acceleration change in time. So our final velocity being 0, our initial velocity being negative 7.5 plus 9.8 change in time. So it means that our 9.8 change in time becomes 7.5, and our change in time becomes this divided by 9.8 becomes 0.77 seconds. So this is the time it took to reach the maximum height, right? And 3.3, it says that determine by means of calculation whether the ball will pass point P or not. So let's take a look at what we have. We know that this point T is at 3.7 meters, but this person threw something at 1.6 meters. So it means that we are trying to calculate the maximum height reached by the ball from this point, and we can add that to this, and then we see if it passes 3.7, right? So Vf squared is equals to V initial squared plus 2 acceleration change in y. So our final velocity being 0 squared negative 7.5 squared plus 2 9.8 change in y. So we can now see that if we bring this side, so it will be negative 7.5 squared being equals to 19.6 change in y. So our change in y becomes negative 7.5 squared divided by 19.6, and you can punch that in the calculator and find negative 2.87, right? Negative 2.87. So now we know that if it is negative, it means that it is going upwards, because our downwards is positive. So now it means that the total distance or the total height reached by this ball will be 2.87 plus 1.6. So 2.87 plus that, let's see what does it give us. 2.87 plus 1.6, that will give us 4.47 meters. So since it gave us 4.47 meters, we can say now therefore it will pass point T. The reason being is 4.47 is greater than 3.7 meters. So that's how we can solve this. So again, I'm going to leave you with this to try on, and then we can do that on the next session as well and see how you are coming along. So try to do this coming 4 questions and we'll see how we can handle your problems on vertical projectile. I hope after these sessions you will be a master and you will be a star on solving these vertical projectile questions. So if you haven't subscribed, please just rush to subscribe, like and share this content with your fellow mates. Until then, see you on the next one.